Hello everyone, in today's video we'll be going over the new challenge category provided by the Hack the Box called Secure Coding, which I really like and I think it's very cool because it's different what we are used to from before. When I initially started, I didn't find much of the write-ups or instructions how to actually play these challenges, so I figured out to make a video giving overview of the challenges, what's the goal of the challenge, how to just generally play it, and also to tackle the first one together, which is already retired. So here I already navigated to it inside the challenges tab. The first challenge we're going to tackle is going to be the resource core or resource hub core. I already started the instance, so without further ado, let's get started and see what we are dealing with. By copying the instance and opening a new browser tab, we can see that we are provided with the HTB or the Hack the Box editor, which seems like an IDE inside the browser. We also have this tour in the very beginning, which is very helpful to see what we are dealing with. So let's go ahead and do the tour together, and then we're actually going to do a deep dive in the challenge itself. So here first we have the File Explorer. A File Explorer is actually going to help us navigate to different directories and the files of the application that we are doing the source code review essentially from the white box perspective. So we have the File Explorer on the left hand side of the screen. Then we have the code editor. So once we open the files, we are actually going to be leveraging the code editor to modify the files, the content of the file itself. Then we have the connection statuses. Obviously, the green one is actually going to mean that we are connected, everything is working just fine, and every change that we apply to the code is going to be applied every 3 seconds constantly, so we don't have to worry about manually saving anything. Then we have the team selection. We can choose among different teams, so as your personal preference, you can choose the one that you like the most. Then we have the restart the service. So once we apply the changes to the code, we are going to be restarting the service for application to take those changes into place, so we can see how the application behaves with the new changes. And then we have the verify, which is going to verify the solution that we provided for this challenge. Finally, we have the view application, which is actually going to provide us the application itself that we are looking in the source code for. So essentially, the goal is not as we are used to before with other web challenges or just the other challenges, challenge categories provided by the Hack the Box, where we want to exploit the vulnerability and to get a flag from the vulnerable application. Now the goal is to find the vulnerability inside the source code, as the name of the category of the challenges says, secure coding. We want to make sure that we are patched the vulnerability, so we implement our fix, remediate the vulnerability, and then if the verification passes, when we click on verify, we are going to be given the flag. So you can kind of think about it as the two separate stages. You first identify what's the vulnerability, try to make proof of concept by actually exploiting the vulnerability, and then after that we can go ahead and apply the patch for vulnerability, which we're going to verify by clicking on the verify. So I'm really excited about it, somehow different than what we used to from the Hack the Box usually, especially from the challenge or the web challenges category, which I also really like. But I also really like this one where we can go ahead and go step above and actually apply the remediation. So I'm very excited about it. So let's go ahead and see what we have here. So navigating to the server.js, we are provided with the not too much of going on, right? So we are using the Node.js Express application. Just before continuing, I'm going to switch a theme that I like the most, which is going to be this one. It's your personal preference, but I like this one because of the colors. So essentially what we have here is the Node.js Express application running on port 8080. We have some middlewares here, and then we have only the one route, which is going to be the challenge. And then we have the console log when application initially started for our reference. So going to the routes, we can see that the routes are defined and coming from the routes or the routes.js. So because of the majority of what's actually happening, applications coming from the routes, we want to take a look first at those. So what we have here is going to be not too much again, we only have two routes. We have the router post to the API upload resource, and then we have another one, which is the router get to the API resources. So let's go ahead and see what's actually happening here. When you send the HTTP post request to the API upload resource, we have the, of course, request and response. We now know that there is a form using the form label. We have the upload directory which is defined up above here. So we have the path being joined, or the path that joined with the current directory where the script is being executed with the uploads directory, which we can see here on the left hand side of the screen in the file explorer. Now currently it's empty. So this is going to act as a temporary directory when we upload the file. And now if something goes wrong, we simply have the graceful stop or the graceful error saying that the upload failed. Now we have some comments from developers, and then now we're getting the files. If we are creating a constant file, now we're getting the as the comment says, accessing the first file from the files object. If the file is, or actually if there is no file, we are returning no files being uploaded. So now this is the most interesting. Now we're coming to the try block or try catch block, where we have the target file name. Target file name is going to be the original file name of the file that we are uploading. Then we have the target path. We have the path adjoint, which is going to combine again the __ dir name with the resource directory. So we can see resource directory is coming here. We have currently 3 files in it: food, power, and water. And then we have the target file name, again, which is the name of the file that we are uploading. And now everything is being joined and combined. And then we are using the fs rename sync for the file path of the file that we uploaded from the temporary directory, and we are moving it to the target path that we have right here defined. If everything goes well, we are having the message to the user that resources upload successfully. Now we have the category, priority, file name, and path being also returned to us. Otherwise, we have the catch of the error or the exception and returning 500 status code to the user, as well as the message resource upload failed. On the other hand, so essentially what it does, we are uploading the file is being uploaded with HTTP post request, and now the file is being moved based to the resource directory, which we're going to discuss in a second what can go wrong here. Before going to that itself, we can go ahead, we have one more route, which is going to be expecting the HTTP GET request, so to the API resources. Again, we have the, this is going to mostly return all the resources or the files from the resource directory to the user, so we can actually see what we have as the resource at the moment. And then we finally have the route home. So before going to the further analysis of the code, what might be the vulnerability here, let's go ahead and explore the application itself quickly just to get a sense of what's going on. So by clicking view here, this is going to open the application in a new tab, as we can see here. So you have the global resource hub. As we know, if we can go ahead and open the burp, I already added the application as a scope, so we are not filtering unnecessary traffic. So we can see here there is a route. As we know, there is only one route to this challenge currently. There is a /challenge. And then we have the API resources, which is going to return the all uploaded files to the resources directory. In this case, we have a food, we have a power, and a water. Addition to the names of the files or the names of the resources, we have the last modified, the size, and path. This is, if you remember, going to be the GET request here, and everything is being returned to us as the const resources, where we have the files that map, we have the name of the files, the path, the size, and the last modified. And then we are returning everything to the user in a JSON format, which we can see here. So we can go ahead and make a note for us. We can go ahead and send this to repeater. And now we know these are the resources being uploaded or the resources that already exist in the resource directory. But what we want to actually do here is actually see how the post request and how the uploading of the files actually works. So let's go ahead and do so. We are in control of the resource file, so we can go ahead and upload. I already created a sample text file called stones.txt, and then we can go ahead and upload the resource. We can see the resource is uploaded. We can take a look at the post request and see how it looks like and what's actually happening. We have, again, post request, as we know, to the Challange's API upload resource with the name of the file. We have the contents of the file. My file is currently text plain. We have the category is going to be power and priority is low, which is itself coming from the UI. We can also change those. Then we can see in response the success is true, resource is being uploaded successfully, category, priority, the file name, which is the original file name, and finally the path. So we know that __dir coming from the here when we are joining the path is going to be the TMP challenge, and then we escape from it, go / or / to the resources directory, as we can see here, and finally our file name. However, what you may already notice here is there is no proper validation of the file name or the target file name. which is going to be the original file name of the file being uploaded. So, which means that we can go ahead and escape from the resource directory using the path traversal payloads and upload our file to the arbitrary location on the server, on the system. So if I'll send this request to the repeater, but before I do so, go ahead and send additional to the API resources. If I repeat this request to the API resources, we can see that in addition to the food, power, and the water we already have, we also now have stones because of our previous post request. So here, if I modify this request slightly and, for example, change the stones to anything, whatever, it can be stones 1, for example, but I modify the file name to include the directory traversal payloads, for example, like this one, because of the simple naive join of the directories. In this case, we have the resources and the name of the original name of the file. We'll be able to escape this directory and upload this file to the arbitrary directory in the system or the web server. So if I send this request, we can see now that the file name is going to be stones.txt, and now we have the path is not anymore, if you remember, going to be the TMP, the challenge, and the resources. Now it's only TMP stones, which means that we successfully exploit this path traversal vulnerability, arbitrary file write vulnerability, by being able to escape the intended directory using the path traversal payloads. So what we want to make sure, for it not to waste too much time of the video here and make this video extremely long, we want to make sure that we are properly validating the file name that's actually being uploaded. So one of the approaches you might take is first go ahead and verify the file names itself, the original file name. It doesn't contain any special characters, for example, dots, slashes, or any kind of special characters that can lead to other vulnerabilities, such as the path traversal one. So that will be the first check that we can apply. The second check that we can go ahead and is actually leverage the path itself coming from Node.js and the built-in methods in it, which we're going to do in this video. And then finally, after we perform all necessary checks, we can do additional check, or the very final one, where we verify if the path being up with the final path that we get from our code logic doesn't start with the directory that our files are supposed to go. We simply reject the request and return error to the user. So without further ado, let's go ahead and see how we can actually fix this vulnerability, how we can actually solve this challenge, because we now successfully exploited it here. What we can do here, navigate back to the editor. So we have application one folder in one tab, and then editor in another one. So we can actually go back and forth and see if we successfully solved the challenge. So if you remember, we want to make sure that the target file name is properly validated. So since we already have a path being defined here, so we are requiring the path and we are having the const path. First thing we can do is leverage the, as you can see, already have the tabs open here, the Node.js path base name, so which is going to extract the file name from the file path. So if you provide any file path, it can be absolute or can be relative. It's going to try to get the name of the file itself. So for an example, we don't have an example here, but we are going to see just in a second. What we can do as a first step to remediate this vulnerability, to apply the patch, is going to be leveraging the path. So we are going to say path.base name, and now we are going to make sure that we're getting the base name of the, in case we provide the whole path as we did here in this HTTP post request. So in this instance, the base name is going to be the stones1.txt. Now the second thing, because this is as itself not enough, we want to make sure that we have the path at join, something that's actually going to be more strict in terms of the our checks in order to prevent the directory or arbitrary file write to the system or the web server. So instead of using the path join, we can go ahead and use the path resolve. And the path resolve is going to be very handy, which is going to create a full absolute path by combining the different parts of the file path. It looks at each part from the right to the left and adds them together, but make sure that we are actually going to have this absolute path being defined in the very end. So we have a couple examples here, which is very handy to understand here. So even if we have // or not // but all dots, is actually going to resolve the absolute path. So for example, what we can do here is go ahead, instead using the path at join, we can use the path at resolve, which is going to take again the dir name, which is going to be the current directory where the script is being executed. Now we're going to be // to escape the resources, because we want to make sure that uploads of the resource is going to resource directory, and then we have the target file name. So for example, what we can think about it is going to be, in this case, we're going to be TMP challenge. Then we can go ahead and think about the resources after these two are actually being joined. And finally, the target file name is going to be now safely validated with the base name. And then we can go ahead and think about, for example, TMP challenge resources stones.txt. And then we are going to have this absolute path here, which is going to perform the file write or the fs rename sync. If we are about to not verify the base name here, that will be a problem. But now with these two controls in place, or these two remediation, without making this video too long, we can go ahead and leverage regex to first check if the file name itself of the original file, or the file name of the file that we are uploading contains special characters. They could be, for example, the first check right here. Then we can finally go ahead and implement additional check right here. They can go ahead and help us to verify if, as a final check, as a final kind of last stage to verify if the file being uploaded or the path of the file being uploaded indeed starts with our expected file upload directory, which is going to be here the resources. But in order to solve this challenge, these two changes will be enough. So here we now have the base name being used, everything coming from the path, so essentially just changing the 2 lines of the code. Then you can remove these unnecessary spaces, and then we can go ahead and restart. As if you remember, for changes to take place, we need to restart application. So it's going to be very quickly. We have restarted the application, and then we can go ahead and try this manually. One thing that I forgot to mention is going to be this exploit directory. Exploit directory is going to contain the Python script. So if you're about to open this at the very beginning of the challenge, you might get the sense of what the vulnerability is, because this is actually going to be this Python script is going to run when we click the verify button in the top right corner. So if we can take a look at it, we can see now the application is actually going to try to upload the file to the static.js, and then it's going to try to access it here. If we can access it, we're going to say, okay, exploit successful, and now we can go ahead and confirm the files are being uploaded to the directory outside of the resources directory. Otherwise, we're going to print exploit failed. Essentially, we are leveraging the Python request library. Then we are defining the base URL for the application running locally, and then we are trying to make request to send the HTTP post request to the upload resource endpoint in order to upload the file. If the path traversal payloads we can see here are working just fine, which is /static.js, which is a completely different directory where the files are not supposed to go. Exploit successful, and this means our remediation fails. And then this is how we know. If you, as I mentioned, if you're about to open this very beginning of the challenge, you might get a sense of the vulnerability, and then you might lose the initial goal of the challenge to actually identify the vulnerability itself by taking a look at the source code first. So I tend to leave this for the very end when I'm pretty sure what the vulnerability is. I apply the fix, and we can go ahead and run it. So there is 2 options here. We can go ahead and straightforward run this verify remediation, but what I like more is actually go back to the application, clicking refresh, for example, to refresh the application, even though it shouldn't be needed because we restarted it, and then try to exploit the vulnerability again to see if our remediation is working as expected. So if I'm about to go ahead and upload the same file again, we can go ahead and take this post request. We see that 200K, which means our remediation didn't break the application so far, and then we can go ahead and try to leverage the same path traversal payloads. So for example, we can go ahead and try to upload the stones1.txt to a different directory other than the resources. And we can see here in the response that we are not able to do so because we are still stuck within the TMP challenge and resources, which is intended directory for files to be uploaded. And then we have the stones1.txt, which is great, which means the remediation works fine, because with the base name, we managed to get stones1.txt. And then with the resolve, we managed to get the, as you can see here, managed to get now nice absolute path for remediation. Now, before going to the further finishing the challenge, you also want to make sure that we also verify this locally and makes it very easy to check and also to understand if we are doing the right thing. So here, for an example, I create a small, simple Node.js Express application. listening on port 3000, and now we simply run it. We can go ahead and run it with Node, and then we can provide the server.js. But before we do so, what we have here, we simply have 3 different console logs. We first have the path base name, so we can actually confirm that indeed, even if we pass the path traversal payloads like we can see here, we're getting only the file name. Then we are going to, just for the sake of the understanding, console log the underscore dir name, so we can see how this looks like, because we can see because the dir, if you remember in the application, dir name is being combined with the uploads. Now I'm kind of pretending here to do the same thing by using the path, the resolve. We can pretend my application is running in the /opt/app. Now we escape from it, go to the uploads directory, and then we have the stones.txt, which is sanitized file name coming from the path base name. So if I'm about to run the application, we have first output that the stones.txt is coming from the base name. So this works as expected. That's great. Then we have the underscore dir name where the script is actually being executed, which is going to be in downloads directory in the HTTP secure coding folder. And then we finally have the console.log, which is going to path resolve. And now we have the opt uploads. Then we don't have app because we escaped from it with /uploads. And then we have finally stones.txt, which means that files indeed will be going where they're supposed to. Final check we have to complete this challenge and to finish it off is actually to verify the challenge itself. By clicking verify, the Python script is going to run, and we can see that we successfully solved the challenge. And that's pretty much it. We can definitely harden more this code, so I think it's really great practice to actually implement all necessary and very robust checks for the file being uploaded. We can go ahead and check for the extensions, we can go check for the MIME types, and also to again check for the special characters with regex, and then finally check if the file actually landed in the directory we want to as a final check. But for the sake of this challenge and the video, these 2 changes that we implement is going to be more than enough for us to get a flag and solve the challenge. So simply getting the base name and resolving the final path. And that's pretty much it for this video. Thank you very much for watching, and have a great day.